Gerrymandering combo. We have Dr. Miller here. I'll give him a brief introduction. I'm Sue Mazzaris. I'm the library director. We invited him to come and speak on this topic. It's very timely and interesting, and hope you will learn something today. So Dr. Miller is a professor at Belmont. He's the chair of the Mathematics and Computer Science Department. He's been here for 15 years. Yep. Is that right? And so I read that his dissertation research was in the field of hyperbolic dynamical systems. I don't even know what that means.
That's okay. Nobody here needs to know what that means.
That's another combo.
Yeah, that's right.
And he's also involved in developing curriculum that focuses on the intersection of mathematics and social justice, which is why we are here. So just a reminder, it is your civic duty to vote. Early voting starts in Tennessee, I think October 17th. So exercise that right, especially this year. So let's welcome Dr. Miller.
Thank you. It's nice to have a small crowd here today. I hope if you ever want to ask questions about anything that's coming along here, or want to know more about something, my intent today is just to give sort of a brief overview of things. We may end a little early, we may not. We'll just see how the conversation goes. There's certainly a lot of issues around gerrymandering having to do with the political process, with voting. There's some math I'll bring in. That's the intent here today. So it's just a deep issue that's really risen to prominence in our public discourse recently. Now, where I came to this topic is through what Sue said about my work with doing curricular development to connect math to social justice issues. And so I've been working on that for about a decade, and in that process I became aware of some of these political issues that surround voting. Dr. Pinner's in the audience here, and when he teaches math classes, he usually talks about different voting methods and some of the issues that arise and some paradoxes and complications. And gerrymandering, as we'll see, is very closely connected to voting, although it's not quite the same issue. And so I heard about a conference that several mathematicians were putting on at the University of Wisconsin in Madison. You'll find out why Wisconsin was the host of the conference here in a little bit. And it was to learn about gerrymandering in a way so that, and I participated in the track of the conference for teachers to learn about how they can bring this issue in and some of the math of it into the classrooms. And so this is my first effort at sharing some of that info with the Belmont community, all right? So where we're going to start is, you may not even know what gerrymandering means, so we're going to make sure you understand why we call it gerrymandering and what it really is, so a little bit of information about redistricting. Then we'll look at some examples that show what the problem is and talk about some of those issues. And then we'll do a real quick highlight skim across some of the mathematical issues that arise when you want to measure gerrymandering or combat gerrymandering, and what we can do about it, all right? Okay, so the quote that's the title here, first off, is a quote that came from the conference. So it's true that there are some legal issues that put constraints on redistricting, which is what gerrymandering is about. But the law only goes so far. And then, as so colorfully put here, then the hocus pocus starts. And we'll see some of that hocus pocus. So first, I just want to make sure everybody knows, I'm not going to assume that you know all the details about our political process. So I want to start to make sure we all know what redistricting is. Okay, so first, we have 435 representatives in the U.S. House of Representatives. That number has been stable for quite some time. In fact, it's a law now that is the number of representatives that we have. Interesting side question, should that be the number of representatives we have? Right? That's something we could change. But the way that so we have 435 and we distribute them proportionally to all the states by population. This is mostly proportional. It can't be exactly proportional because some states that have very low populations are guaranteed to get at least one. So for example, Wyoming has one representative in the House. They cannot have fewer than one because there's no such thing as less than one person. In the same way, you can't have fractional people that represent. So this is actually, in and of itself, an interesting mathematical problem to decide what is the fair way to distribute a collection of indivisible units proportional by population. And there are different methods that have been talked about, but that's a talk for another day. So what happens is that the two things trigger redistricting, and they all have to do with the census. First of all, every 10 years, when we count the population of the states, we redistribute the representatives to all the states. If there's a state that goes up in population significantly in proportion to the rest of the country, that's going to gain a representative, and that representative has to come from some other state. And so they reshift all of that. The other thing that happens with the census is it gives you information about how population is distributed within each state. So how do those two things contribute to cause what we call redistricting? Well, so each state is divided into congressional districts. So Tennessee has 9 congressional districts. We have 9 representatives in the House of Representatives, the U.S. House of Representatives. And we have to divide the state up into 9 areas that are the voting blocks for each representative. For example, Davidson County essentially elects 1 representative. The city of Memphis elects a different representatives, and so on, spread throughout the state. And so the state, and each state is a little different. The state divides up, draws lines to say all the people that live in this area are going to vote for representative number 1. All the people that live here are going to vote for representative number 2. All the people that live here are going to vote for representative number 3, and so on. So the state divides that up. So the number of representatives determines how many districts you get. Population also affects districts because their court case in 1964, that was the source of our phrase you often hear, one person, one vote, that says that each congressional district has to contain about the same number of people. This was a result of a Supreme Court case that was brought by some rural voters because they, it was the urban voters, other way around, because there were some very large in area districts but low in population because they were mostly rural areas that were electing a representative, and then there were some urban areas, high in population, low in geographic area, that were also electing a representative, and there were many more people per representative in the urban areas than the rural areas. And so what sort of the distortion that causes is that proportionally each person's opinion in the rural areas was worth more than the urban opinion because that representative was voting for fewer people. Right? You can imagine this in the extreme if there's a district that contains 1 person versus a district that contains 100 people or 1,000. That one person's opinion is more important because if that representative is listening just to them, or in the extreme case, if they are the representative, their opinion is the only thing that decides the vote for that representative. Whereas those 1,000 people all have to compete with each other to convince their representative how to vote. Okay? And so that Supreme Court case ruled that we must have 1 person, 1 vote, and so all congressional districts have to be approximately equal population. The deviation can actually be pretty big, plus or minus 10% in general, which to a mathematician is not really very close. You can do better, but that's the legal standard. And so when the census counts all the people, they find out how many people live where, and you have to redraw the lines to say, okay, we need to make sure our districts are equal population. It's all based on census data. And so, of course, the districts change over time in interesting ways. So this is Tennessee right now. You can see already, this is our congressional map, you can see already some interesting things. And I know this pointer works. Okay? So here's us, right? This district was pretty normal, right? It's very small geographically because there's lots of people here. This is a tiny geographic area. This is Memphis, right? So all that population is concentrated there. They get 1 representative. We have 1 representative. And then some are much bigger because they're more rural. You can already see some interesting things with this map. This looks like an ordinary district, pretty ordinary. This looks pretty ordinary. Looks like there might be something going on with this district, okay? Now, if I were to group things together to make roughly equal population, I might not do something as wiggly as this. And then right here, we have this strange district that is connected by this tiny little line right here, but it extends all the way north-south here. So whoever that representative is, that represents District 3, represents all the people of Chattanooga, but also all the people that live way up north in Oneida. That person is supposed to represent all of those people. And many of the others look the same. Now, it's a little hard to see in this color, but there's also something sort of weird going on here. If you look at this, there's this little finger of purple that sticks out, and this little finger of pink that sticks out over here. Some sort of weird carving going on here for this district right here. And so that's where we start to get into what we call gerrymandering. And just so you can see how Tennessee has evolved, the historical perspective, let's click over. I already have this open. So just so you can see, just compare how the districts have changed. So you see here, all the districts look roughly nice shaped. And then we start to get some weird shapes, and then more weird, and then even more weird, right? We got this blue district is really kind of crazy. If you know Tennessee's population geography, this again looks like Nashville. This is probably Franklin, Williamson County. And then we get to today's, which looks a little bit better, okay? So we go from some maps where the districts look relatively ordinary shaped to other maps where you have a lot of crazy shapes. Okay? Now, one thing to be so this is where we get the name for gerrymandering. Okay, so districts that are weird shaped have been around for a while, and so this was originally published, you see here, in 1812. This is area of Massachusetts where we have a voting district that is this long, sinuous district that somebody thought for some reason looked like a salamander. And I guess salamanders in the 1800s had wings. So it's they called it a salamander. Ever since then, a district that's weird shaped has been called a gerrymandered district. So that's the historical part of the name. Now, how can we get these weird shapes? The fundamental building block of a district is a census tract. So every district, because of the way we have data, every district is put together by a bunch of census tracts. And so these are, so you know, the census tracts for our area. You can see Belmont is right here, right? I think. In this map, it's a little hard to see. Isn't that Belmont Boulevard right there? Maybe not.
Yeah, I think so. It's in that area.
I think so. So here's us. We're in census tract 169. And then here's the surrounding area. And so to build a district map, you connect census tracts. So the border of every district has to be borders of census tracts, because that's where we get the data. That's the smallest level of population data we have from the census, which is who lives in this block, how many, and what type of people are they, from a demographic perspective. So that's where the gerrymandering comes along. Because when you draw these maps, you don't just try to, ideally, in an ideal world, you just say, okay, we need to group people together that have some similar concerns, and we need to make sure it's roughly equal, and you'd stop there. But of course, this isn't a perfect world. We have a very divisive two-party system, and that influences the way we try to draw the maps. Because we also have lots of data about how people vote, how they have voted, how they're likely to vote, and that data comes down not just based on, sometimes it's based on the individual people, sometimes it's based on racial characteristics or income characteristics, but we have lots of models that can reliably predict how each census tract will vote. And so we get situations like this, okay? So here's 50 precincts apportioned into 5 districts. So on the state level, you can think of these as precincts, but you think of these as census tracts on the US level. And we have 60% of the voters want to vote for yellow and 40% want to vote for green. And the way we draw those borders change the outcomes quite a bit. If we draw the borders like this, you'll see that each district, right, because voting, the votes for that district go to the ultimate winner in that district. We see that this district vote will elect a yellow representative. And this district will elect a yellow representative all the way down the line because there's more yellow voters, right? And so yellow wins. So we have 100% of the representation in this, this legislature is yellow, even though 40% of those voters would like to be represented by green. And here you can get, you can do something else. You can have the minority voters have a majority of representation. So it's a little bit trickier to see what's going on here, but you can see that we're drawing lines in really weird ways. So we're grouping together all the yellow voters so that we have some landslide victories in the, these precincts and just a little bit of green here. And then we're concentrating all of the green voters into 3 districts so that they get to elect green there. And so now we have 3 green representatives and 2 yellows. And the reason that this is considered undesirable again is that 40% of the voters want to be represented by green, but green gets 60% of the representatives. And so if the legislature here is passing laws by majority rule, which is typically what happens, the green legislation is going to be more likely to be enacted, which will annoy 60% of your voters. So over here we have perfectly proportionate outcomes. So we have, what that means is the proportion of yellow representatives is equal to the proportion of yellow voters by dividing it up in a different way here. Okay. So here we're seeing some of the things that we talk about. This is called packing. This is called cracking, because you're splitting up all the green voters and spreading them out so they're ineffective. Here you're packing the green voters together and packing the yellow voters together, for that matter, which causes these weird things, right? So you pack all the yellow voters together so that there's lots of wasted votes because they win in a landslide. Right? There's way more votes for yellow than you need, and you pack all the greens together so that they can have a better effect. So what does this look like in some other positions in the country? So this is one of the most famous gerrymandered districts in the entire country. We'll see some other famous gerrymandered districts. You can see that this district, there is nothing ordinary about this district. It is stretching all along here, and you can see that it's drawn to capture Charlotte and Winston-Salem. And I think that was the main goal for building this district, to make sure all the Winston-Salem and all the Charlotte voters, because urban voters tend to vote Democrat, push them all together, right? So we don't have to worry about 2 districts that are going to elect a Democrat, just 1. So we only have to worry about 1 Democrat. This is what North Carolina looks like now. You'll see that that infamous District 12 is not there anymore, but we still have some weird shapes going on around here, and maybe a little weird here. The dark lines are county lines. One of the goals some legislatures, one of the rules some legislatures have for districts is that they should, when possible, follow natural borders, like county borders. So there's some counties that have to get split up. You'll see that a lot of the borders follow county lines in many, many cases. Okay? This has been ruled unconstitutional. Where the big debate comes into play and where court cases arise are when people say, this is unfair. You've drawn these districts so that you are benefiting your party. For example, in Wisconsin, the Republicans had control of the legislature. And in the state of Wisconsin, so when it was time to redraw the districts, so they drew the map in such a way, predicting voter behavior, that when the next election was held, the Republicans had 60% of the state seats, the seats in the state assembly, but only 50%, actually less than 50%, 49% of Wisconsin voters voted for Republicans. So in a perfect world, it would be a tie in the assembly. But very differently, the Republicans had 60% of the seats in the assembly, and they did that by drawing the districts in such a way as to influence the outcome. Gerrymandering, it's important to say, is not just a Republican issue. It's not just the evil Republicans. Democrats gerrymander.